Alright guys, so what we're doing today, obviously like the title says, we're going to be learning our average value and mean value theorem. Not necessarily new concepts, they're still just integrating. It's a definite integral. It's just a different way, it's algebra heavy. Okay, so it's a different way of, not a different way, but different use of it. So average, what does average mean? Well, they mean the same thing, right? Average and mean mean the same thing. They're so average is when you do what? What do you do? Good. You add them all together and divide by the number you have. And remember, um, when you're integrating, what are you really doing? Well, yes, it's area under the curve, right? It's area under the curve. And so then, if I'm asking you basically an average of that, I'm asking you, okay, so what's the average of all the area? Because remember, a definite integral is the summation, right? It's the adding together of all an infinite amount of rectangles under a curve, correct? So I'm at this point we're saying, okay, well, what's the average of it? And so it's actually a pretty simple addition, a fix to what we're doing. So the average function value of a function f of x over any interval a to b is given by, this is the way we abbreviate, f average, 1 over b minus a. And this, obviously, just means however many you had, right? Because b minus a is your interval. Let's say it's 1 to 4. 4 minus 1 is 3, so 1/3 of all that. So basically it's cutting up, it's divvying up your total summation, the integral from a to b of f of x dx. Okay? So really the only difference now, this is f average, AVG, just abbreviation. F average, function average, is equal to 1 over b minus a, the integral from a to b f of x dx. So really this is the only addition. So at the front of your interval or integral, we're just adding that part to it. Okay? Because we know how to do this. We know how to do this. It's just a regular definite integral from a to b, the integral of f of x, whatever it is, dx. And then now we're just going to multiply in the front by 1 minus b over a. Okay? So it shouldn't be that much different. So here we go. This is our first example. This should be very short today. Okay? Determine the average value of each of the following functions on the given interval. So determine the average value. This is how they ask the question. Okay? This is how they ask the question. Determine the average value. Now, nowhere in there does it mention anything about area under the curve. Doesn't mention anything about taking an integral. But this is where you come in and say, oh, I know what we're doing. The average value. So that means we're doing f average, and that's 1 over b minus a, integral from a to b of f of x dx. Okay, so that's what we're going to use. When they're asking for average value, we're going to use the formula that we just learned. 1 over b minus a, integral from a to b, f of x dx. Bless you. Bless you. Okay? Alright guys, so set me up. Five halves plus 1, right? So we're going to, from -1 to 5 halves of that function. T squared minus 5t plus 6 cosine pi over t, and then of course dt. Alright, so let's simplify this right here. Let's simplify this right here. This says 1 over 5 over 2 plus 1. 5 over 2 plus 1 is really what? 7 over 2. So this right here, this is 1 over 7 over 2. And of course I don't want that either. So simplify that. How do you simplify that? You take the reciprocal of the bottom, right? So this is technically 1 over 1 over 7 over 2. It becomes what? 2/7. Okay? So it's just 2/7. And then let's integrate. Let's integrate. or not equal. So this 2/7, just like before, always gets multiplied by everything. So integrate for me. 1/3 t cubed minus what? 5/2 t squared. So what you notice, what we're looking at over here, guys, if you look at this part, it's a little more complex. It's a little more complex. So we're going to have to do a mini u substitution right here. Okay? Just a mini u substitution. And you can do that. You can do it on parts. Because remember, we have a rule that says anytime you're adding and subtracting terms, you can technically think of them separately, right? And that's what we do. I integrated that separately than that. So I'm just doing it every piece by piece. So I'm only on the back part, I'm going to use a little mini u substitution here. So if if I was doing u substitution on just this, what do you think my u would be? Probably just the pi t, right? And now, don't get freaked out because pi is just a what? A number, just a constant. So imagine if this just said 2t, right? So what would be its derivative? Just pi, right? Just the constant. Because if it was 2x, the derivative would just be 2, right? So in this case, the derivative of pi over t, or pi t, is just pi. Of course, dt. What's the problem? There is no pi. There's a 6 there. So then what would I do to get rid of this? Divide by, no, 1 over pi. So guys, this is like a constant. This is a constant that I'm just going to kind of take. You know how you can take out any constant? So imagine that 6 is not there. It's going to be back. But so right now I really need 1 over pi du to give me my dt. Agreed? So then when I come back, I'm really going to be left with what? This 1 pi goes out with my what? So that's actually going to be 6 over pi rather. And then it would be cosine of u. And what's the integral of cosine? Just sine. And then I do not want to change my limits here. Why? Why do you think I don't want to change my limits? Because this other part has limits already, right? In terms of t, I don't want to have to change this one in terms of u, because then I'll be dealing with two different integrals. So how do I make it to where I don't have to change my limits? Put your u back. So instead of leaving it as sine of u, it's actually going to be sine of what? Pi t. Okay? And then of course that's all from 5/2 to -1. So do you see how I did a little mini u substitution on that back part? Okay, and you can do that. So when you notice things like that and saying, look, I can do the front two, but this back part looks a little bit more complex, so I'm just going to kind of think of it separately. Just do a u substitution only on that, and that's okay. All right? All right, so then now, what do you think I would do here? Good. Distribute this 2/7. This 2/7 has to go to everything. So in the end, it'll become what? 2 over 21 t cubed. 10 over 14, though, I can reduce that to what? 5/7 t squared. Then I would get what here? This is going to be weird, but what do I get? 12 over 7 pi, and that's okay. Sine of pi t from 5/2 to -1. So now, guys, I want you to plug that in for me and tell me what you get. I'm going to pause because it's going to take a while. So remember, the easiest way to do this one is put this in y1, right? And then basically you're going to turn this into y1 of 5/2 minus y1 of negative 1. Does everybody know how to do that? Everybody knows how to do that? Like, when I put this in y1 and then pull it up? No? So, go put this in y equals, right? Did you put that in y equals? And then when you're... So, if you go put the equation in y equals, it was alpha 2 over 21 x cubed minus 5/7 x squared plus 12 over 7 pi sine of pi x. So put it in y equals, and then how do I pull it up? So if you do alpha trace, it gives you the option of all the y equals you have. So of course ours was in y1, and then you just put parentheses here. It was 5 halves. Close that parentheses minus alpha trace y1 of negative 1. That's it. So it saves you time and having to retype everything, right? It's just saying, here, use the equation I gave you in y1, here's the first x, minus the same equation, here's the second x, and then you should get that. Did everybody get that? So then it's approximately negative 1.621. So this represents the average value. So this is the average value of this integral, or of this function, from here to here. It's the average value. Literally exactly what it sounds like. If I were to plug every number from here to here, which you realize would be impossible, correct? You realize it would be impossible for me to plug in every number from here to here. Why? There's an infinite amount of numbers between any two numbers, right? So it would be impossible for me to do that. But the integration allows me to do that. And this is the average function value. So if I were to do this, if I were to sit here and do this forever, right, until I die, most of my numbers would come out to around this. That's what this is saying. Most of my values, the function values. So these represent x's, correct? So from negative 1 to 5 halves, if I were to sit here and just start plugging in negative 1 into this function, and then negative 1 point, no, I'd be going the other ways, negative 0.099999, right? And then, trying to get to 5 halves, the average y value would be this. Does everybody understand that? That's what this is finding. It's finding the average function value. How do I know it's what? It tells you average value. When it says average value, because like we said earlier, they never mentioned anything about integration. But it's like what I'm trying to explain to you. It's impossible for me to do this by hand because we said there's an infinite amount of numbers between any two numbers, so I couldn't do it. But the integration allows me to do that. Okay. Let's try another one. So it says determine the average value. Again, there's that word. Determine the average value of each of the following functions on the given integral. So, determine the average value. My function is r of z equals sine of 2z e to the 1 minus cosine of 2z. Does it look easy? No. You got a bunch of dad jokes is what it is. I need to up my game. So, looks complex. So, have an idea maybe? What we might use? Alright, let's see if that's going to work. Alright, so, first of all, my formula, it's 1 minus cosine of 2z. 1 minus cosine of 2z. Okay? So, my formula again is function average is equal to what? right? 1 over b minus a of the definite integral of this function. Okay? 1 over b minus a, definite integral of this function. So plug it in for me. What would I get? 1 over pi plus pi, which of course is 1 over 2 pi. Agreed? 1 over 2 pi, because it becomes 1 pi minus a negative turns into plus, so there's 2 pi's. The integral from negative pi to pi of sine of 2z e to the 1 minus cosine of 2z. So we kind of already hinted towards it. Probably, what are we going to have to use here? Okay, so which one do you think is going to be my u? Why? Why do you think that that's the better u? Okay. So the easiest way to think, I think about it this way, I say, look, if this is u, then it's just e to the u. And what's the integral of e to the u? Itself. So it's the easiest thing to integrate. Because remember, that's the point of u substitution, is to make it to where the integration is easy. Agreed? So u is going to be 1 minus cosine of 2z. Yeah, thanks. So therefore, guys, what is du? So, what rule am I going to use here, actually? It's a chain rule, because there's a function. So first of all, does everybody realize the 1 doesn't matter? Right? So it's basically, I'm looking at a negative cosine of 2z. Right? So then, but it's the derivative of the outside times the derivative of the inside, right? So the derivative of the inside is what? 2. And then the derivative of the outside is just sine, and then leave the original of 2z. Does everybody agree with that? Of course, dz. I forgot my dz over here. So, does that look like what we have? Pretty close, except what? That 2 in front. So that's easy fix. What do? Half of it. So I only need half of du. Would give me the sine of 2z that I need. dz. Agreed? You with me? So then this goes 1 over 2 pi. And then that 1/2, I'm going to bring it out, correct? Times a half. The integral from negative pi to pi of this and this become my du, correct? So it's just basically going to be what? E to the u du. So, good question. Do I want to change my limits, or do I want to just plug in u? What do y'all? It doesn't matter. You want to change the limits? You sure? I wouldn't. And the reason is, because it's just going to be 2 pi. Cosine of 2 pi is the same thing as, remember, 2 pi is the same thing as what? 0, right? Because it's a full circle. So it's the same thing as 0. So that this thing comes in handy today, right? So I'm gonna just say leave it. So in the end, this is gonna become 1 over 4 pi. 1 over 4 pi. The integral of e to the u is what? E to the u. So it's just going to be e to the what? From pi to negative pi. Okay? So this looks complex, guys, but we're smart. We're going to do this one in our head. So you realize that I'm going to plug in pi here, right? So 2 pi. What's the cosine of 2 pi? Keeping in mind that 2 pi is the same thing as what? As 0, right? So cosine of 0 is the square root of 4 over 2, which is really just what? 2 over 2, which is just 1. Okay, so keep that in mind. So this says e to the 1 minus 1, which is e to the 0, which is 1. So this is just 1 over 4 pi. Okay? Minus, now let's plug in the negative pi. Let's plug in the negative pi. Is that going to matter? Because it'll be a negative 2 pi now. What's the difference? It's still 0. What makes it negative? Different direction. So instead of the first time on my circle I went counterclockwise, now I'm going, but I'm going to end up, you see I'm still in the same spot. So this is still going to give me what? 1. 1 minus 1 is 0. E to the 0 is 1 times 4 pi. 1 over 4 pi. So actually, what do I get here? 0. Now, see, a lot of students get confused. They're like, sir, how can your average be 0? But remember what we're talking about. I'm just saying, for the most part, if I tried to plug these in by hand an infinite amount of times, most of them, not all of them, but most of them, because that's what average is, right? Average doesn't mean everything is the same. It's just saying that they're all kind of going towards this one direction, right? That most of them would be close to what? Does that make sense? Yes, ma'am. Okay, you're smarter than me. Oh yeah, and well that would have been easier then, huh? Because the integral from 0 to 0 is just 0. Oh, but so you see now you see that it wasn't a mistake. Okay, so good. I'm glad I caught that for you. All right. So guys, average value. Average value means to do what? You're just going to integrate from a to b. The only difference is now you times this. Got it? Times this. All right, last thing. Let's talk about the mean value theorem. Okay? The mean value theorem. So it says the mean value theorem for integrals says this. If f of x is a continuous function from a to b, then there is a number c in the interval from a to b, such that this is true. Okay? That there is a number c such that the integral from a to b f of x dx is equal to f of c times b minus a. F of c times b minus a. So this is the mean value theorem. Basically saying that the definite integral at some point is equal to f of c times b minus a. F of c times b minus a. And you realize f of c just means c plugged into your function, some number c plugged into your function, and then b minus a. Alright, so I put some notes here. It says, look, the way to think about the theorem is basically, if I rewrite it, so you see how I was being multiplied by b minus a? If I divide it, then it was the same thing as saying 1 over b minus a. So what is this? The function average, right? So basically it's saying that from this theorem it's telling us that there is a number c that's equal to the average function value right here. There is a number c that at some point in this interval that there's a number c that is equal to the average function value. Basically saying if f of x is continuous, then somewhere between a and b, the function will take on its average value, which makes sense because if it's going to be the average, at some point it has to actually equal to that, right? You can't have an average and that never actually get there. It has to be there at some point. So that's basically what we're doing now. Using the mean value theorem, we're going to say, okay, find me that c. Find me where that happens. Okay? So what we're doing now is from this interval from a to b, remember this is an infinite number of numbers from a to b, I'm actually finding the point where it actually happens. What x does it actually happen where you're going to meet your function, your average function? Okay? Not necessarily middle, but at some point, right? Because it just depends on your curve. If it was a straight line, then yes, it would be in the middle. But these curves have different things. So, how does this work? All right. So notice here, For the most part, guys, when they want you to use the mean value theorem, they're going to straight up tell you, use the mean value theorem. Okay? Or sometimes they abbreviate it as MVT. Okay? So MVT, mean value theorem, means use the thing you just learned. Or the formula that we just talked about. It says, determine the number C. Determine the number C that satisfies the mean value theorem for integrals for the function f of x equals x squared plus 3x plus 2 from the interval 1 to 4. So, my mean value theorem says this. The integral from a to b of f of x dx is equal to f of c b minus a. That's my formula. So this, to me, guys, it's kind of like an algebra problem. It's an algebra problem. Because I have a formula, and I'm just trying to figure that x, or in this case, that c, out. Okay? This is what's, to me, this is very algebra heavy. Alright? You have everything you need. I know what f of x is. I know what a and b is. So what do? Plug them in. Right? You have a formula, so plug them in. So, when I plug in, what is this going to look like? The interval. Well, we can do either one. So you can either leave it like this, or you can do the average value one. It doesn't really matter. You'll get the same answer in the end. But in this case, I kind of want to just use the true formula. So let's just plug it in. It'll be what? The integral from 1 to 4 of x squared plus 3x plus 2 equals to, what does this mean? Meaning what? Plug in c. So does everybody realize that this means c squared plus 3c plus 2? Right? Times b minus a, 4 minus 1. You with me? You with me? Okay, so when you have a formula and you're trying to figure it out, you just kind of work everything out, right? Do the algebra, and then in the end try and solve, right? So on the left side, can I do that? We know how to do that, right? It's just a definite integral. So integrate for me. 1/3 x cubed plus 3 halves x squared plus 2x from 4 to 1. Agreed? Do me a favor. Just give me that answer already. Because remember, it is a number. Just give me that number already. So what is the definite integral of that left side? Just give me that number. And quickest way to do this, Hector, is what? y1, or put it in y1, y1 of 4 minus y1 of 1. What is it? Give me that as a fraction. Should get 99 over 2. Okay? So on the left side I have 99 over 2. Left side I have 99 over 2. Let's work with this right side. Obviously 4 minus 1 is what? 3. So what am I going to do with that 3? So I'll get what? Three c squared plus 9c plus 6. Okay? Alright, so look. I've gone from calculus to algebra. Now I'm just in an algebra problem. How do I solve this algebra problem? Before I factor, what does it have to be? It has to be equal to 0. Before you ever factor, it has to be equal to 0. Okay? So it would be 0 equals 3c squared plus 9c, and then I would have to turn this into what? 12 over 2. So, because it would be minus 99. Negative. Yeah, yeah, yeah. My bad. So it would be a minus 87 over 2. All right. So, good question. How do you factor that? So, okay, you can. The easiest way to get rid of a fraction is to do what? Multiply. So you can multiply everything by what? By 2. That would make it this 6c squared plus 18 minus 87. And then how would you factor that? Yes. So what this turns into, guys, is you cannot factor this. Now, you don't know that unless you try. You don't know that you can't factor this unless you try. But so then, guys, this is, like I said, this is an algebra problem. How do you solve something that you cannot factor? Your good old quadratic formula. You remember that bad boy? So this is your tool in solving for anything that cannot be factored. Actually, even if it can be factored, you could still use this and it'll still solve. This is the highest order solving. This thing works all the time. Okay? So, do I know my A, B, and C in this case? Yeah. Alright, so let's plug it in. Actually, it's not X, it's C this time, right? So let me... Doesn't matter. So C equals... it'll be a negative what? 9 plus or minus the square root of 9 squared minus 4 times 3 times negative 87 over 2. All of that over 2 times 3. I would say simplify this a little bit for me. So let's do this is called your discriminant. There's just the stuff underneath the radical. What's 81 minus 4 times 3 times negative 87 over 2? You have a calculator. This right here? $603. Okay. Yeah, and then how do you solve this, people? You actually do this. So what you got to remember is while you're doing this, how many equations do I have here? 2. A negative 9 plus the square root of 6 over 3. Square root of 6 over square root of 603 over 6. And then negative 9 minus the square root of 603 over 6. So y'all should be able to give me my two answers. Give me my two answers here. I get two answers because obviously I have two equations. So what is negative 9 plus the square root of 603? All of that divided by 6. Negative 9 plus the square root of 603. All of that divided by 6. 2.59 what? 3. Okay, now what is negative 9 minus the square root of 603 over 6? Negative 9 minus negative 5 point what? 593. So I get two answers. I get two C's. There's one problem. My interval has to go from what? 1 to 4. So guess what? This one does not apply because, why? It is not in my interval. Is this always going to happen? No. Can it happen? Yeah. Okay? So I get two answers, but one of them does not make sense because the only one of them's in my interval. My interval went from 1 to 4. So this is my answer. What does this answer represent? Good. It's the point from this, it's a point inside this interval. Remember, the infinite numbers between 1 to 4, right? The infinite numbers between 1 to 4. Here is the one x that when I would plug it in, it is actually equal to the average function value. Okay? Yes, this is like my average x. Okay? So this is what the mean value theorem helps me do. The mean value theorem helps me find that one number, possibly, maybe happens twice, that one number where it actually equals to the average. Okay? And that's what you're doing with the mean value theorem. Any questions? These can get they're just algebra heavy. Are you always going to have to use quadratic formula? No, hopefully sometimes you are able to factor this. And you will be sometimes, okay? But just keep in mind that it has to be within your interval. Okay? That's probably going to happen more than you think. And then just use your formula straight up. Any questions?